Good morning. Forward compatibility of data and logic. First, we'll look at our existing backward compatibility and our approach to versions and what that requires. So backward compatibility is for an application to run on all previous versions of logic and the information structures that it creates. It has to be consistent, and backward compatibility says, I created an application and I have a existing. We don't have very many programs that actually implement this completely or sufficiently, if you wish. A few of our current applications are backward compatible. Intel CPU instruction set. You can still run 8080 instruction sets on the Intel CPUs or MS, Microsoft's Office, Excel, and Word. I don't know if they force you into, it's a huge problem. It requires changes to the source code. So all of our information is defined and structured from the source code. So we have one piece of source code and it creates or manages one data structure, or a set of data structures, if you will. And this limits enhancements to the application. If you want to be backward compatible, then you're going to be limited to the basic concepts of the original approach. So we can't go in and make major changes without affecting previous versions. And sharing is much, much harder. People say, I have an old version of Word. Okay, it gets me by, but people send me the new version of a document. I can't open it. So and that's the most common document out there. We waste a lot of time with not being able to be backward compatible. We lose a lot of our existing information. Pixar lost Finding Nemo images, and so they had to recreate them only 13 years later when they tried to do Finding Dory. And this is just one example, but getting to archives, and your archives might be remote, so you may not have access to them to update them, and it can make your existing data useless. New applications and must be purchased. So what am I saying is forward compatibility? It's for an application to be able to run on all future versions of logic and information structures. Means that we can change the information that we store on disk and can have the assurance that we'll always, at any time, be able to access that information with all current versions or backward compatible. By default, when we say we're forward compatible, we're also backward compatible. Now, forward compatible says, okay, I don't care what you do to the information or to the logic, we can always access it. So all information is basically application, hardware, and operating system independent, meaning that they cannot affect the information. Therefore, applications and information will last forever. You may not have the new capabilities, but you can still run on that same application 100 years from now. And this allows technology to change at any time. Right now we're stuck with technology we cannot change, basically because we have one format for a DLL. We can't enhance that. And all of this is totally transparent to the user. That's what we need to go to, is the user doesn't even know that it's being done, but it is. And it's completely handled by Jane, the system I'm building. And there's no overhead for the users or the developers. So it's basically, it's done. You don't have to worry about it. It's being handled. So we should look at the requirements for forward compatible. It's actually a new technology of a cell, a blob of or data, something. It's whatever we decide it is, but it can contain a data structure, just like a file or whatever you want to, a blob of information. But it also must contain its details, its name, its format, all the context and data types and all this. And that can be contained in a cell. But it can also contain physical and logical partitions by rows, columns, and context. This is required because we're trying to store a lot more information, a lot more knowledge about every piece of information. And that information must be segregated so that we can access only the things we want to access, even though it's a whole part. So this is critical. So if I had an image and I said, okay, look, I have 9 more images that I want to, and I want it in one cell, one file, if you will, then I should be able to put all 10 images in one file and logically access them independently without referencing, actually having to read the other cells. And so a cell can contain folder containing other cells. So it can act like a folder, if you will. We'll get rid of file and folders on our disk drive, and we'll go directly to a cell, which is far, far more complex. There's much, much more to it. I think I have a video on that. And it can contain other related cells. Means that, let's say I have a table and I want to store another cell that is a index to that table. Or let's say I have history that I want, so I can contain things that are specifically related to my data structure. And I need to know that these are, when I copy this cell, that I'm going to copy everything in it. Or I could copy pieces of it. That's why the partition is so critical. So we must create or have a stable term vocabulary for the required values. So if I have graphic point, then I need to know that somehow I'm going to identify the coordinates and use terms that mean something to everybody. X, Y, and Z would mean something. Latitude and longitude would mean something. But if I try and call it something else, then it's not necessarily going to know that if we simplify it. The details of the data structure is going to tell us exactly what's in there. We're going to put more and more knowledge into our cells so that our applications never have to wonder or guess at what is the capabilities of this particular data structure. And so we need to be able to transfer qualified structures into and out of memory. And this is all automated. So when I say qualified, it's kind of synonymous with an SQL for tables. SQL references tables. It'll let you qualify a table and give you a resultant data set. And this is the same thing here. We need to be able to qualify our structures and move them in and out of memory at will automatically just from a name. So if I say employees, I can say employees, and the system already knows where it's at, what it contains, security and everything else is automatically applied for you. And then if you say, look, I only want the employees that live in Texas, then I could do that. I mean, that's where the qualification comes in. And that is all through the namespace. And all of this is implemented inside the compiler. So I'm writing, and actually it's a much, much larger system than just a compiler, but I'll use a term that people recognize. And basically it says, I will do all this work for you. You just simply, I will give you a language that you can tell it to do that. You can say, look, partition it by these columns or by date or month or something. We'll be able to, geographic regions. Okay, here's cities. Let's segregate our database physically by city or state or something, whatever our criteria is. Well, thank you for your time, and until next time, thank you.